So we're full. I mean, we have. We're beyond like. We're not like a simple web app. We have a lot of like sort of stream processing and data processing services that we also have to do. I spend a lot of time working on those things. I spend a lot of time writing REST APIs, and I spend a lot of time writing tests. And REST APIs are pretty much a solved problem from my point of view. Like, you can talk about how you want to do them and what libraries you want to do, but it's pretty clear like what you want to do most of the time, and your concerns are more about like optimization of like how long something takes. But architecture, at this point, like a lot of people know how to do it. So I think that what's missing from when we were working, because we have a large PureScript front-end application as well. It's like pretty big, and I think it's relatively complicated on the scale of things. It's a large single-page app. If you want to hear about it more, we can talk about it later, or you can talk to Rockley because he wrote almost all of it. So the difficulties were in building a bridge between sharing types was the original goal. There are several libraries that facilitate doing this between Haskell and PureScript. One of them is called PureScript Bridge. That is deprecated or abandoned, I don't know. Another is called Servant PureScript. That uses, so PureScript Bridge is just to generate types and instances for things that are useful, like generics or new types and stuff. You can also it generates lenses for you as well. It doesn't, you have to implement certain type classes in Haskell using this PureScript foreign. PureScript Bridge uses, I guess, some kind of servant foreign or something in order to help figure out what those types look like. I'm not actually sure now, it's been a while. But basically, anytime you use these libraries, they're so out of date, you're going to end up forking them, or forking a fork, and uploading it as you build out an API or shared types library to facilitate whatever it is that you're working on. So it's a constant sort of like race of like, oh, the front end needs to do this, and this API needs to do this, but the libraries don't do that, so now we need to update the libraries, and this just goes on and on. So trying to get out of that doesn't involve getting rid of Servant or Haskell, so it involves doing something else. I'm going to talk a little bit about Servant because I don't know that people here have all developed REST APIs in Haskell. Servant is a REST API framework. It's basically a collection of libraries. The core one is the type-level DSL for building APIs. I'll give some examples of not Servant itself, but the things that we wrote. But I'll just talk a little bit like why it's really good. It's usually it's awesome because it kind of takes the like networking part out of building REST APIs unless you really need to go there. It makes it really just about writing Haskell functions to implement a server, or you might want to do things like implement a client for a REST API or other types of things that it facilitates very well. So it's definitely a tool to abstract the details of building out servers and mostly just talk about writing functions that connect to databases or WebSockets or whatever else you want to do. The things that you get for free for this type-level DSL is the core, so it's kind of the intersection of all the libraries. All the libraries share this type-level DSL typings, and they do different things with it. So they either use it to generate the sort of harness for the server code, or the harness for the client library, or in this case I have listed a few things over here. It's something called a Swagger file, client library, Markdown documentation, JavaScript client libraries, or in theory PureScript client libraries, although that's why we're here in the first place, is that doesn't actually work very well. If you don't know what Swagger is, I have a link here to an example. Does anybody here not know what Swagger is? Cool, so Swagger is like, if you like curl, then you probably will like this. So it's like basically a Swagger JSON file is it's just I don't even know how to describe it. It's a JSON file that describes an API in whatever level of detail, and a Swagger file is used to generate these UIs also to help you kind of just navigate a REST API that you may not be familiar with and try it out in the browser. And so you get these things for free, and I mean literally for free. Like, they just are artifacts. If you just plug in the library and put in some generic instances, then you just get all this stuff. I'm not going to go through, so there are comparisons with other REST API frameworks in Haskell. I personally don't see the point of using any of these anymore for myself, but lots of people like them. So Yesod is kind of like Rails for Haskell. There's like, it does a lot of stuff. It can take like, some kind of configuration file and generate things. It does a lot of template Haskell to make web development pretty straightforward and simple. Snap is like also very similar feeling of like kind of doing a lot of stuff for you, assuming that you want to like make these little applets and connect them together like Legos or something. Scotty is something that seems a little bit more lightweight, and I know it has a cool router, but I don't really know much about it. But in my mind, Servant is the one you should be going to if you don't know what else to do. Servant foreign, Phil mentioned this. It's a help. It basically is like helper types and functions for generating client functions for Servant APIs in any programming language. It's basically a way to take the type level DSL and bring it down to the value level so that you can build up these data structures which help define the things that need to be written to a text file ultimately. So you end up with something like so here's an example. Also, I forgot to mention. So like these kind of you can generate, Axios or Angular client libraries. So, for example, this is the Foam API generated as a Axios JavaScript library. The way that it works is that using Servant foreign in some Axios-specific library or component of a library, it builds up data structures of the routes, and it knows what Axios functions exist, and ultimately is just generating text files from some collection of Haskell data structures. And yeah, that's the basic idea. Servant foreign, this is really hard to, I think it's hard to do for any target JavaScript client library for a number of reasons, because the Servant is a very Haskell, it is like the Haskell library par excellence. It is like probably the most sophisticated, largest, most sophisticated Haskell library that I'm aware of, if you exclude things like Postgres or like ORM type things. Like, I think that on that order, maybe you could argue that like persistent is really complicated and uses something crazy. It's a very high octane library. Opali is another one I think is competitive with this, but like on the order of things, Servant is using the most bells and whistles of the Haskell type system of any other libraries that I really know of, which means that this thing which is supposed to bring it down to the value level has got a pretty big job. And there are several things that make this hard, like type level functions that have been incorporated into the routes. So for example, I have a few examples here, like this, if the internet works. Okay, cool. So like, here's an instance, for example, for like, so you want to have like headers, you want to define headers in the route. There's some type level function here which is very crude, but it's clear to me that it's using some kind of type level function called fold lenient. So like fold lenient, fold required. It's basically like some kind of hint to how to parse a header. I don't even know what, but I've tried to bring I'm pretty familiar with how to use like Servant foreign, and I have a hard time doing this. And I think it's always a race to basically keep up with what these Servant people are doing. There's also some other combinator libraries that if you incorporate these combinators into your routes, that you're going to have a hard time supporting them, because the way that it works is like the combinator system for Servant is extensible, so you can add things in that are not developed as part of the core Servant library. Servant auth being the most probably useful of those things. It's not a part of like the standard. So when you include that combinator, basically, there's no support for in let's say like PureScript or Servant PureScript, then you're going to get an error that's like, I don't know how to deal with the Servant auth combinator, and now it's up to you to basically write that yourself, and that happens for everything that you want to do. And some of them are pretty experimental, but you want to use them anyway. I always plug my own stuff whenever I can. So I wrote this pretty cool experimental Servant library like 2 years ago that nobody ever used, but it's actually the first introduction I got to PureScript, because when I wrote it, the only person who ever responded to this asked me if it worked with PureScript, and I said, I don't know, I'll have to get back to you, and that was like 2 years ago. So I don't know, I still don't know if it does or not, but it probably won't, because this This is a cool library. I don't know if you're familiar with the concept of like server-side loading or something. So you have like data types that have lots of foreign keys in a database, and lots of times if you just do a naive query and you end up just returning some object which has a bunch of foreign keys. Like in this photo album has like an album ID, and a person ID, and a photo ID, and like this item itself is pretty useless to any app, but like it gets returned sometimes, and then they end up making like return queries to get things that they might want to fetch later. This is a library which can help you very easily turn something as boring as this into something as exciting as this without doing any extra code, without writing any extra code, basically. So it's, if you're interested in this kind of thing, this is one of the coolest things I think I've made that nobody cares about. And so there's no serving foreign, there's no serving PureScript support for that. And I don't think you can write that actually. The client, I implemented a client library for this in Haskell, so it does work with serving client, but the client is dependently typed. So I don't even know what you would have to write two things. I don't know what you do in PureScript. And basically what I'm saying is that this library, so here's the link to the library, this Eskimore. I'm unclear as to who this person is, but a lot of their things have fallen out of play, it seems. So yeah, there's no choice. You can't do this. That's probably Phil has similar experience. It seemed like they also like pursued this for a little bit, but they decided not to go there. So I'm basically arguing for doing something natively in PureScript, not only because the one that you want to support, which is the servant, which is servant APIs and Haskell applications, but also there's other things that you might want to do, like write PureScript client libraries for things that are not Haskell applications, like you don't even control them, like you have to talk to Salesforce or something, or whatever. Salesforce is the only thing I can think of. But if you had to talk to it, what do you want to do in order to generate a PureScript client library for it that's well typed? You're basically talking about writing the types in the servant level DSL and then implementing some boilerplate type classes and then using that to generate a PureScript client library that's clean for you. That sounds ridiculous. Like, why don't you just do it in PureScript itself? So if you're looking, this actually happened recently, so Foam uses this library that I'm describing, or going to describe, for its application, its primary web app that it uses, but I've also factored it out and used it in several side projects that we've had going forward that talk to like some server written in Go that I don't even know what it does. So this thing is called purescript-servant. I don't have, I'm just going to bring it up. There's a link to it later in a different slide, but I'll just bring it up. So, purescript-servant. It's a pretty small library right now, but basically it was a proof of concept to show that you could do something like this, and that it's probably worth doing, because I bet every company that represented here is a PureScript development company probably has their own way of generating HTTP requests or whatever. And I think that there's a lot of things that people write that are in common, and I think that the thing that Servant did the best was unify a bunch of patterns into a very simple language that was expressive enough to take care of like any REST API functionality. And I'm advocating that you could do something similar in PureScript. So what PureScript-servant is like Servant itself, it's a type, it's a type level DSL for describing APIs, and it's written in PureScript. It has a similar flavor of the list of combinators, but it's not exhaustive, and I don't think it has to be. I think Servant probably will forever do things that people in PureScript don't care about, like streams, for example, there's a lot of streaming support that got put into Servant in like the 15.16. There's like machines and conduit and pipe support for streaming large files. I don't know that people, like if the primary use for this is for generating client libraries for front-end developers, you might never have to do that. But the important part is that it's a way to transform an API type into a client library. For me, that's like the immediate selling point. I just listed some of the combinators here. They look probably really familiar if you're used to looking at things like this. How you basically build up foreign data in PureScript. So there's a foreign kind called route. It's a way of basically introducing a new kind into the type system that didn't exist before. There are several different ways to make a route, or you might consider it actually a route component. Either just a path, a string, which is part of a path. You can have a capture, or something that's sometimes called a slug. For example, in this case of this GitHub, this GitHub URL, my username is capture. Query params, I think everybody knows what those are, who's ever interacted with the REST API. And or headers, and then there's verbs like get, post, delete, or whatever, and then there's a way to basically take these primitives and build routes out of them that probably end with a method or a verb like get, post, or delete. So that's an example of these combinators. And this is what it kind of looks like when you write it. It looks exactly like Servant, because I think Servant did it right, so there's no point in reinventing the wheel. There's a couple of things that you can do better with records that we do better, I think. So for example, like here's an example API for like a client API for like posting, for some kind of application that deals with photo management, like Flickr if it existed. So you have parts of paths which are prefixed by things like string or s or whatever. So the route for this post new photo looks like it's whatever the root URL is /photos/user, and then it ends with like a /user ID or whatever. And then possibly for posting purposes, you need to include like an authorization header with an API token as its value. And then this is represented here as a post method using the post route constructor. It inputs its body is a photo, and its return value is no content, because whatever. I think that so this is slightly different than how Servant does it. They have something called like a rec body combinator, but that actually doesn't make sense for like GET requests, because most servers will like totally ignore a body for a GET request anyway. So you get some kind of things even there that don't they type check, but they don't make sense. Here's an example of a simple GET request using a capture. This one's pretty straightforward, I think. Here's an example of how you might use query params. Here's like a search endpoint, so it's rooted in /photos, and you can search using any of the query params. There's a distinction between query params which are required and which are optional, and query params which exist in more than there's more than one possible value for them. So, for example, here's a record of query params like the before date, the after date for the publication of the photo. The owner could be any possible number of users in this list. And let's say you have a cursor, which is a way to basically indicate like a limit and offset in a search. So like you want to search, from the beginning your offset is 0 and your limit might be 100, but then your next request, your offset is going to be 100 and your limit might still be 100, so you'll get the number, you'll continue to basically, it's usually used for things like infinite scroll. So that's kind of like the example of like the type level DSL that I'm talking about looks like. The implementation for the user is pretty straightforward. It's obvious if you've used Servant, if you've implemented, if you've written servers using Servant before. I think it's pretty similar to how they do things, except the types are a little bit simpler maybe. So you have things like toCapture, toHeader, and encode query param, where these things are used to take whatever value you're talking about and turn it into a string in all of these cases. So for example, because at the end of the day, a header is like a string or whatever. So as long as you have a way to take an API token and turn it into a string, implementing that toHeader class for API token, which might just be show or whatever. In a similar way, you need a toCapture for this user ID because you have declared it as a capture, so you can just show it or whatever, however you transform it. You implement those things as the user of the library. And then under the hood, I just talked about this for a little bit because it's not important to understand why this whole library might be useful, but basically the idea is that each route gets inductively folded into some data structure, which is called suspended route. And it's just basically a data structure that carries with it all the possible information about the request which is being made. So here, for example, it has a query string, it has a path, it has headers possibly, and it has a request method. And then basically there's a simple method that we use to do this in all possible cases. It's a class method called route builder. This is where this is a whole thing is a pitch talk. I'm not telling you that like this this is not the library. What I'm saying is that this is probably useful, and that I don't have time to do all this by myself, and everybody here knows these things, so maybe like a suggestion and input is desired. But this is where it starts to diverge from Servant, especially because Servant has You could do this kind of things, I know, with like functional dependencies, but in the way that they're done in Servant, they're using something called, associated types. And so the way that Servant reduces, basically folds, so if you have a type which represents a route, which is a bunch of little components separated by this caret operator that I showed earlier, then you can start to fold over the components and build up a type which represents like the actual thing which is the class is going to build for you. Here, it's supposed to build a suspended route at the end of the day, but what I'm telling you is it's unclear to me using the PureScript type system how to avoid including all the possible fields of a suspended route in the type class itself. And we can talk more about that later if you have any ideas or you don't understand why that's important in the first place. It just gets verbose is what I'm saying. And so, for example, here's an implementation for how do you fold a path component, a string path component into a route. This is a symbol, so you can use reflect symbol to get the string value of this thing, and then you simply just compute the rest of the suspended route without that, because there's this inductive hypothesis here that you can build the route itself without the string component. And so what you then do is okay, fine, we go ahead and we get the string that we're using to build the route, we build the rest of the route, and then we cons the path component onto the rest of the route that we just made. It's a very vanilla pattern for things. I'll come back to that later. I realized it was vanilla only at the end. And so, let me make sure there wasn't anything else. So that's an example. There's other examples for query params, captures, headers, etc. are all equally boilerplate. And that's the point of PureScript, I think, is just to make things easy via boilerplate. And as little as possible, right? You want to do as much meta programming as possible, but whatever's left at the end of the day should just be boilerplate. If you disagree with that, then that's fine, but I'm just tired, So, how do you, okay, so let's go, let me just go back real quick to, oh God, no. Let me go back a few slides to just familiarize you with the type implementation example. Where's the examples? Here we go. Okay, so here's the get search photos. Again, I just want to remind you what its type was. It's it has a path component that's just photos, and then it has a bunch of query params, and then it's going to return, via get request, it's going to return an array of photos. So I just want to show you what that looks like when you write the function itself. So the function itself, this is now part of what I would call the client portion. So the point of the client portion of the library is take the type level DSL and turn it into a bunch of getters and posters and deleters, etc. So you want to make functions which do something that is dictated by the route. So if it's a get request, it's basically a function that returns a result. If it's a post request, it's a function that takes some data and might return a result, it might return like a unit or something. If it's a delete request, similar thing. So now we have these types, we want to turn them into functions. The way that it's done is very similar to Servant. So there's something called a client environment, which basically keeps a connection manager, or in the case of PureScript, just a URL for where the API is that you're talking to. A way to possibly deal with AJAX errors, because under the hood this thing uses AFJAX. A monad AF instance, so basically this is the context for any API request that you'll ever have to do with us. And then the only input to this function, because the original part again was just like a path component, which doesn't require us to do anything, it's just going to magically append it to the path that we're going to hit. But the only input to this thing it turned out to be that you needed query params. Query params before were, maybe we wanted to talk about the posting date, we had an array of address. The only thing which is actually kind of unique here is that required thing doesn't become an identity. The required query param just disappears, it becomes the data itself. So there's no way, you don't need to wrap it or unwrap it or whatever, it just needs to sit there. And then this thing returns an M of an array of photos, and the way that you do this is by using this thing with this library primitive, which we have because we don't have a smarter way of doing it right now, which is build get request. And then you give it a route proxy, which is the type that has the proxy of the type that I just scrolled back to show you. And then it fills in all of the arguments because I don't know a way to do this. I don't know a way to basically make the variaticity of the function depend on the types or whatever. So I don't know how to make this function not take captures, query params, or headers, etc., because that is complicated, or at least not straightforward, at least not obvious to even somebody who has experience, I think. And so there's these, kind of these no captures, and then okay, the query params can pass through, no headers. Everything requires a decoder and an encoder for figuring out how to get to deal with your content types. We don't assume that you just make JSON requests, although that's probably what you're doing, so we provide some defaults. But basically these decoders, and there's a typo here, I think that I just copied decoder twice instead of the encoder, but okay, so just ignore this, I'll fix it afterwards. But there's a type for what a decoder and an encoder does. It's pretty obvious. A decoder, a parser takes a string and produces either an error or something which is parsed, like possibly JSON here, or maybe HTML, I don't know. And then a way to decode that JSON or HTML into whatever the value is that you're actually looking to get out in the end. So there's some intermediate parsing phase, possibly, so to get JSON, because you want to get the best errors as possible, like it wasn't valid JSON or whatever. So, and then we provide some defaults. If you just want to do JSON, then that's what we do almost all the time, then you can do that. Its current uses, just to show that this thing isn't just like some toy project that we made on, before we got here. The foam map itself, which is a closed source repository for no good reason at all, other than that it's just, that's the way it is. We don't have any reason to keep this stuff private. It's not like it doesn't have any company secrets in here. It's just not a public repository. Originally this library was embedded in an application and it's still there. But it was factored out also. It just hasn't been, this application hasn't been updated to use the standalone library. But anyway, there's tons of requests here, and they all have the same flavor of what I'm talking about. You define a type, and then you use our boilerplate functions in order to get you some real purescript function that is basically like a monad ask and a monad error m to perform the request for you in that context. So I don't know, there's probably like 30 routes here or something. The benefit of doing this also is that there are certain routes which always, before we switched to something like this, using servant purescript or whatever, were just they just wouldn't work. And so what you'd end up doing is, like I said, you'd have to fork the servant purescript library, and you have to update it or whatever, because you're gonna include this information in your API, and you need it available. And you write a custom shim function for just that one route that wasn't working for some reason. And then this requires you inside of servant, your server code itself, to separate the part of the API that works with the bridge from the part of the API that doesn't, and then use what I call the bird face combinator to combine them. And this just allows you to just do it all in PureScript and not worry about what works with what bridge library and not, and it's about the same amount of work. The difference is that you're not going to get that always up-to-date feature that you're looking for. This is a library which is specific to stuff that foam is interested in. It's not particularly easy to explain what it does, but it's a client library for some kind of futuristic ayahuasca blockchain application that it's experimental. But the server for this thing is written in Go, and I wrote it, and it was a miracle that it works at all. But the one thing that we were able to do here is that we're able to generate a client library for this magical mystery box that we don't have to deal with writing Go to write tests for this thing, even though that would be the quote-unquote easiest thing to do. We do write them in PureScript because we were able to wrap the API in this relatively simple way and use the existing other PureScript libraries that we have to talk to Ethereum. There's a similar library, okay, so there's another one of those kind of things that's just linked in the slides, but that one's private because it's also, there's no reason to keep it private, but it's under development, so there's no point in doing anything public. And then there's this library called PureScript-Trout. Trout arguably has a better landing page than we do because of the fish, but it's not very well developed. There's nothing in here, I think, relative to what you actually want to do. There's a server Trout and stuff. It's unclear to me and Hyper Trout that uses something called Hyper. I don't know what this is. I tried to post an issue. If anybody knows I had to figure out Owikstrom, then you should ask them to respond to this request that I'm we basically are interested in similar things. Can we just merge the efforts or work on something together. If knows who that is or works with them, they should contact them and ask them what's up. The last little bit I have, because I have just a little bit of time, we're still in the 30-minute range, is I just do a plug for this PureScript heterogeneous library. Because I thought that I was always being really clever. I was always developing all these inductive type class definitions, and I'm like, oh, I'm really smart because I seem to be able to really hack the system here. And then I found this library which basically did everything that I ever thought I was doing, which was cool. But as soon as you get over that, you can start to write really terse code. Okay, so the plugin for this, what this library does, if you don't know, is oftentimes you want to take a record, which is whatever key, keys mapping to different types of values, and you want to fold that whole record into something. So here's the best example that I can come up with. It happens to be my own. It's an example of how to what you're replacing and so this is the diff for before and after the PureScript heterogeneous library was used. So let's find something like non-trivial header. So basically, all I want to do, what is the headers of a request are like a bunch of tuples of string and string, right? It's like the header name and the header value. That's this tuple of string and string, and then a request has multiple of those things, so it's an array of tuple string string. And so what you want to do is take a list of a record of headers, and turn them into that list, and then you can appropriately build a request later once you're in a more sane place where you have that suspended route type I was talking about. But the goal is to take, let me go back. Here we go. This is a record of headers. There's only one in here, but you can imagine there was also a content type or whatever that header is. I think it's a content type, right? Where you tell it what you're looking for. And so this could be a record, and then the other value could be this, the string content type, and then the value could be some enum type of JSON or HTML or text or whatever. And you want to turn that record of now two objects into an array of tuple. Where is it? What? Oh, here we go. So what you do is you figure out if your record is actually the empty record, and if that's the case, then you return the empty string, and then assuming that you know how to make a record of headers out of all the other stuff, and you have a new thing with key S and value type A and some other stuff, which I don't even know what it is because it's just stuff that has to be there when you do this kind of set theoretic arithmetic on records, and it's this is all stuff, I've written this kind of thing 100,000 times in different forms. And the way that you do it is, of course, the standard way of inductively you build the rest of the list, which you can do because you made this assumption here. You build the key value pair that you have talked about introducing to this, or consing onto that record, and then you just go ahead and append it to the list of tuples that you're talking about. So this kind of thing happens all the time. And for example, this is a way to do it with PureScript heterogeneous, where you're taking what's called a fold over a record, where the symbols are actually, where the keys in the record are actually important in producing the final output. And it's a fold in the sense of this is the accumulated value, an array of tuple string string. This is the new type of value that I'm trying to fold into that in conjunction with this symbol, and the output is going to be this array of tuple string string again. So that's the target of the fold. And it's super easy to implement this stuff once you blur your eyes, and once you learn how to do it, it's actually easy. It looks really complicated when you read the library. My one critique of the library is that the type variables are all X, Y, and Z, and they don't really explain what the things are. So somebody coming at it from a totally new point of view, it might help if those things were called accumulator and folder or whatever. I know that it's once you get it, and you never have to go back, but that initial barrier is kind of a lot. And then I just want to show you, so as a point of how you can grok that library, if you just look at it enough, I'd like to show off what I did this weekend myself, is I wrote this function, which does something really complicated, but does a lot of folding over records of various kinds, and doing various different operations. Like here, for example, I'm folding into an empty record and producing some new record. I'm like folding into some monadic array of variants, which is like, you can do anything with this library. It's pretty cool. I'm folding into like monadic actions and all kinds of stuff. So you can do like monadic folds over records as well, and it's really cool. So yeah, the whole point of that was just to say again that like, you know, this library has now gotten actually substantially simpler from using this purescript heterogeneous in a way that like, in a similar way that like I was talking about, that, you know, servant uses associated types to do like folds over routes. It's pretty cool. This is a pitch. If you find this kind of stuff interesting, you should talk to me or write on GitHub. Again, the repo is called foam purescript-servant. And then if there's a website for this hack, I didn't fill out a talk because I actually wrote this morning, this talk. So I will update the list and you will find the slides there. And if you find this kind of thing interesting, we should work on it. That's it. Are there any questions?
I was just going to say, for like the variadic arguments thing, I mean, I think the easiest thing is just to have like a record of you can.
Yeah, we should show me like what you, I mean, if you could show me it either in text form or later over issue, that would be awesome, because I'm having a hard time understanding right now because I've never seen it done before. But thanks, yeah, we should talk.
The OOXM guy, I think he's no longer doing purescript stuff, so I doubt he's going to respond to that issue. Because I think he's the one that did the purescript spec library before they migrated to somewhere else.
Okay. Well, that's fine. We know we're just going to do it anyway.
A question to you, or maybe the audience, like for this purescript-servant. I mean, I know that people run sort of like full stack Node apps, right, where your server is also in Node. Would it be potentially interesting to like replace Haskell servant with purescript-servant and run a server more than just gluing stuff together?
Yeah, so if you're interested in running servers in PureScript as well, I have never done it, so I don't know what the popular libraries are. But what you would want to do is you would want to fix that in advance, in the same way that servant fixed WAI is like its underlying machinery for implementing the web server itself, because the servant is just a DSL on top of it to abstract away the WAI portion unless you actually want to go there. So what you want to do is identify what is your target server library that you actually want to use to implement these things. And then you would want to build on top of that. And I haven't done any work in that direction because we write all our servers in Haskell. So, but that's the only reason.
Does anyone know a bit what one would use?
Over here writes some servers in PureScript. What do you use?
We have a little tiny stuff we use. We use like serverless kind of setup. And we use it's sort of handy. It's like just starting process and stuff. So it's more convenient. We use something called quick-serve that I wrote. So it's kind of like servant actually, but it uses records rather than goes on kind of record things. So it's a little bit nicer.
Cool.
You can totally hook it up to your library. You can like go there, generic.
Cool. Should look at this.